So how does one actually see radiation? It's common knowledge that you can't see or taste or smell or feel radiation. It actually adds to a lot of anxiety about radiation. What if I told you there's actually a way you can see radiation? And that's called a Wilson cloud chamber. Cloud chambers have actually been the source of discovery in the field of physics for decades, for as long as nuclear science has been a thing. In fact, they discovered the positron in 1932 and the muon in 1936 using a cloud chamber. Now, in a Wilson cloud chamber, we typically have a warm side and a cool side. The cool side in this one is a aluminum plate that's put on top of some dry ice. The warmer side is actually a felt surface that is soaked with isopropyl alcohol. Isopropyl alcohol in this felt will evaporate and float down onto the aluminum surface here. What will happen is, as that vapor floats down to that aluminum surface, which is super cold, it will turn into a super saturated vapor. And this vapor really wants to condense into a liquid phase, but it can't. Ionizing radiation, such as beta radiation or alpha radiation, will come into this supersaturated layer and interact with it. As it's interacting with it, it's imparting its energy to it and ionizing that supersaturated layer. And what happens is very similar to what happens in our upper atmosphere. It creates a condensation trail. Now, while you're not actually seeing the physical beta or alpha radiation, you're actually seeing the trail behind the alpha and beta radiation. It was a cloud chamber not unlike this that actually inspired me to be a radiation scientist. And it's my hope, after building this cloud chamber here, is to inspire a new generation of radiation physicists.